Hi everybody, I'm Ivan Morgillo. I'm the author of Rx Essentials and Gratis ebooks for Kindle. It's a popular app, it's a companion app for your Kindle. You can download a free book from Amazon. So if you read, and I hope you do, you can enjoy the app. We'll talk about RxJava and reactive programming for the next half and something hour. You will learn the basic things. You will learn how to move your code from old imperative to future reactive thing. And we will solve a few problems that we daily have on Android. Reactive programming was an idea by Eric Meyer back in Microsoft. He realized that he could bring a few ideas from SQL, mindset, and observer pattern to daily programming. A couple of years later, Ben Christensen, formerly Netflix, now in Facebook, and we all hope that it will be good in Facebook because they really need help. He realized that he could save us because we are Java programmers, so we deserve to be saved. And he released the RxJava that basically targeting the JVM. So you have everything's Rx closure, Scala, everything that run on a JVM. And reactive programming is based on the concept that data flow. You have this concept of sequence. You can think about like a river, and you don't really have control on data. Data is in charge. And it's based on the observer pattern, the gangs of 4 observer pattern, new concepts. But they were hard to implement in Java, and so we enjoyed the new way we can use them. If you think about a river, you can realize that you have to approach the thing like in a push approach instead of a pull approach, because data is coming to you. You are not pulling the data. We have daily, in our day, we basically have the observer pattern everywhere because we expect the things come to us. We don't check our emails. We get a notification. We don't check WhatsApp. We get a notification. If you think about a spreadsheet, you have a bunch of data cells with numbers, and you have a total cell that sum the data you have. You don't update the cell manually. You don't check every second that you are changing the data. You expect that the cell updates itself when you change the data. And it's even a microwave. You just set up, subscribe, and when everything is done, you ding, and you have a notification from your microwave. The main players are the observable, that it's the emitting entity, so he generates the values, and you have the observer, that is the receiving end of the question, and you have the subscription, that it's the entity that manage the relationship, because when an observer subscribe to an observable, you get a subscription in return, and you can use it for check if the observer is subscribed, or if you want to unsubscribe. Basically, it's the status of the relationship. You have the subject, that it's the fancy guy of the crew, because it can be at the same time an observable and an observer. It's useful in lots of edge cases or specific scenarios that you need flexibility and heavy decoupling. The relationships basically is implemented with these 3 methods. The observable just push the new data when the new item is available through the onNext method. Basically, it's an interface that you have to implement as observer. And when the new data comes in, you get it in the onNext. When the data are over, when the sequence is complete, you have an onComplete. And when something goes south, because shit happens, you have an onError. Let's use a fancy animation. Smooth. That's the idea. Time, the observable emits item, and you get it in the onNext, and you use the item. Piece of cake. Let's do something real. We are going to create an app. It's a very fancy list of my installed apps. Standard stuff, recycle view, bit of material design, nothing complex. We are retrieving the list, and basically we are providing it like an observable sequence of this type app info. We create a normal Java class that returns an observable, a Java function actually, and we do our create observable.create, and we add a new object to the sequence. When it's ready to be propagated, we just push it in the next. When the sequence is complete, we just call onComplete. Actually, the create in this example is kind of forced because we are looping on a list and emitting the items one by one. RxJava has a bunch of methods. Basically, there's a method for everything. So if we already have a list, how can we create an observable from a list? From, easier. So if we have a list, we create an observable from a list, and observable.from will emit every item in the list one by one until the end of the list. I don't have a list. I have 3 elements. I want to emit just these 3 elements. How do I do it? You're cheating. Come on, you use a SoundCloud, you use RxJava, so you are out of the games. Guys, you just keep the, okay? So we have observable.just because I have just 3 elements and I want to emit just these 3 elements. So observable.just 1, 2, 3, and we have the subscriber. So I want to emit nothing, and I want just complete the sequence. So I have an empty sequence. Come on, an empty sequence. Yeah, you're getting there. Observable.empty just doesn't emit anything, it just complete. It could be useful testing, edge case scenarios, just to try some method outs. I want an observable that doesn't emit anything and never complete. Never complete? Ah, Jesus. Never. Yeah, come on. You're getting there. Basically, never complete. You can use it for testing purpose or checking some timeouts or stuff like that. I want an observable that doesn't emit anything, doesn't complete, and just throws an error. Oh, Jesus. Can you move, up front? Because they are kind of sleeping. Did you get wasted last night? No. So let's go. So you have a bunch of method to create the observable you want. You have the fur if you need that. So this is the first set that you can be using. Android. So we have our basic stuff. We have the recycle view. We have the adapter. We have the fancy swipe refresh layout. We have our list. We get the list, and we subscribe with an observer. And then what? Yeah, what? This is the observer. So the observer just implements these 3 methods. We receive an app info object. We add it to the list. We refresh the adapter, and when the sequence is complete, we just show a toast because we want to notify the user that the sequence is over. And if something goes south, we show an error and we stop the progress bar. So we have the list, we have the sequence, and we have the 3 behaviors that we want in any scenarios of the processing the sequence. And we have something like this. Easy. But why should I use RxJava? Why should I learn RxJava to populate a list? I already populate lists. That's why you don't believe me that this stuff is useful. So because there is a lot more. If you think about filtering, you have a sequence that you don't manage. You are not responsible because apps are coming to you. So it's a sequence that you just process. You don't generate, and you have this new boss that doesn't like apps that don't start with a C. You just want apps that start with a C. You should receive the list and filter only the apps that starts with a C. How can we do that? Oh, you're cheating. Yeah, you are always the same one. Come on, please sit there. And we filter. Observable.filter. We pass the condition. RxJava will take care of evaluate the condition and propagate only the items that satisfy the condition. And we have a new list with only the apps with the C name. The observer, it's still the same because it was waiting for a list of app info objects. Nothing's changed from his point of view. Too long didn't read. I have a list of apps, but I'm lazy. I don't want to read all the list. And I want to list the first 3 app in the list. I want to just take... Oh, Jesus, come on, you are cheating together. Shame on you. Take. Why not? I have a sequence, I want just the first 3 elements, and I take the first 3. The observer is always the same, so we call it Jon Snow because he knows nothing. He's just waiting for the app info object. So this is the end. My boss is lazy. He's the kind of guy that jumps to the end of the book and he just wants the last 3 apps in the list. How can we take the last 3 apps? Guys, this is rocket science. And we have the last 3 elements on the list. I had duplicates. We are not in charge of the data. The data is in charge, and we are receiving this sequence from somewhere. And we want to be sure that we are processing one element just once. We don't want duplicates. In this example, I have the installed apps list, and I have no duplicates because you can't have duplicates because you can't install multiple times the same app. But we have RxJava, so we create our list. We take the observable. We take 3 elements. We repeat the observable, and know what? We have a sequence of 9 elements full of duplicates. So we created the scenario. How we get rid of the duplicates in a sequence? Oh, nice. This thing will analyze the emitted items, and it will be sure that there are no duplicates. Obviously, this works with a sequence that's complete because he has to analyze all the elements. How do we work with an ongoing sequence? Where are the relier guys? We have a temperature sensor that it's emitting every second the current temperature in the room. So it's 25 below, 25 below, 25 below, and we are updating a display. Every time we get a new value, we update the display. So basically, we are updating the display even if the data is not changing. How can we prevent this to work on a conservative way? Distinct until change, because why not? It's English. So distinct until change will filter out every element that it's equal to the previous one. And we are getting only the new one on an ongoing sequence. And it's cold, so it's Jon Snow at the wall. OK, the sequence is kind of more light now, but we are still emitting and receiving, theoretically, an element every second. The temperature won't change that quick, so we want to slow down the rate of emission of the observable. So we can create a new observable from the first one and sample it. Basically, we are providing a time amount and a time unit, and sample will mirror the previous observable and will emit only the last element in a 5 minutes window. So we are getting only the last one. And if you apply distinct until changed, we will emit every 5 minutes, theoretically, the new element only if it's changed. And we have the observer that it's always the same. If we need the first element, there is a method for everything in RxJava. So the window is basically the same. It's 30 seconds instead of 5 minutes, but the throttle first will take the first element in the time window. Do you copy? I'm talking to you. OK. Enough filtering. Just to throw you a couple methods more. We have take, but we have skip too. Skip and skip last. If you need to skip the first element, for instance, and you know that the first element is some kind of control element, you can use skip. Transforming. We have these new marketing guys, and like programmers, we work with what we have. So he comes and he say that we need every title to be lowercase. We want to change not so much code. We want to reuse the observer. We want to apply a function to every emitted item to create a lowercase version of the name. We use map. Map will apply a function to every emitted item, and it will emit something. In this example, we are emitting again an appinfo object, so we can use the same observer, and we are getting a new list, lowercase names. But we could emit everything. We could receive an incoming list of appinfo object, and we could grab, for instance, just the bitmap, because we want a list of bitmaps, for instance. So we'll apply a map on every item and extract the bitmap and emit the bitmap. The observer will be different, but that's the idea. You have a stream of data, and you create the stream you want, applying functions. There are a lot of transforming functions. The easiest thing, cast. For instance, if you have to cast the item, every item to some other kind, other type, flat map or concat map, because if you are doing a lot of RxJava, at some point you realize that you are creating very many small function that returns observable, and you would like to chain them. You can use flat map and concat map. That basically they are the observable equivalent of the map. Or buffer, for instance, if you want to receive a list instead of a single item, and you can process a list of 3 elements at a time, for instance. Buffer will create a buffer of 3 elements and emit them as a list instead of as a single app info object. Combining, what's that if we have 2 lists? We have our list, the classical one, the apps list, and we have a list that is the same but is reversed. So it's the same type of object. And we want to combine these 2 lists. We won't merge them. Oh, gee. Huh? Come on, you are already skilled, guys. Observable.merge. And we pass the 2 observable, and they will create a single observable, and we will provide them to Josno. We want to combine 2 kinds of observable and combine them with a function. So we have our list, we have a new observable, it's a TikTok. We create it with the interval method. Basically, we are emitting along every 1 second. It's just emitting along. We want to combine them using this function, update title. Basically, we are taking the long and we are concatenating the app info name and returning the app info. How do we do that? With zip. We take the 2 observable and the function, and that's it. It will take care of everything. And Josno is always waiting for app info object, so it will be all the same for him. And now, enough theory, let's go to the Android world. We know that Android has even JavaFX. Basically, lots of platform has the UI thread concept. So you have to do everything outside the main thread, because if you do stuff on the main thread, your UI will some kind of lag. And you know, if you want a proper user experience with a fluid UI, you do the heavy stuff on another thread. And in this example, we are reading our list from shared preferences. We just save the list and we are grabbing it. So we create an observable. We read the string. We parse the string with JSON so we can create a list. We have the list and we start pushing the list to the observable. Everything is cool. We are using RxJava. We are cool. And then we enable strict mode. How many of you use strict mode? Strict mode is a tool by Android. And basically, if you enable it on your debug build, it will just point out that you suck at programming. It will notify you that you are wasting time doing stuff on the main thread. I mean, reading from the SD card or reading from the network. And in logcat, you will see something like that. Discrete violation. We are wasting 253 milliseconds reading the list. So we suck. We are using RxJava, but we still suck. We are not cool enough. How can we do the job on a different thread? Probably async task is the answer, you know, because no, we are using RxJava. We are safe from that kind of nightmare. And it's 2015, so we are not dealing manually with threading because, come on, I'm too old for these things. And we have schedulers. We have just subscribe on, and we provide scheduler IO that is basically taught for IO operation, and we are reading from the SD card, so it's cool. And it will take care of execute everything that is before the subscribe on a different thread. We run the app. We don't have a discrete violation anymore. And the app explodes because that's That's the thing. Only the original thread that created the view hierarchy can touch its view. Makes sense, because we are providing the list to the recycle view. So we are getting the data from another thread, and we are trying to change the UI that has to be changed being on the main thread. And it's getting kind of tricky, because we should do the job on a different thread and get the result on the main thread. So probably the async task is the answer. And no, because we have RxJava, and we have observables, and we have scheduler, and we have observe on. Basically, we are saying, do everything that is here on the scheduler IO thread, and everything that is here on the main thread. So we are doing the heavy stuff on a scheduler IO, and we are receiving the result on the Android MainThread. And basically, we are doing concurrency with two-line code. And guys, allow me. Deal with it. So we have no excuse to suck anymore, because we have plenty of tools to do our job properly. We can do multi-threading with just, two lines of code. I have this heavy function that does, very important stuff, and it's not I/O related. So how can we use RxJava to do something like this that will provide something like this? You are basically skipping a few frames because you are doing a heavy computation thing, that loop, that important thing, and you are getting these if you are lucky, or that for sure on a log cut, and we will apply the same concept of the scheduler I/O, but it's not I/O related. We are doing computation, and you know what? We have other schedulers, because there is a scheduler for everything. If you do computation thing, you have scheduler.computation. If you want to do something now, you have immediate. If you want to queue your computation, you have trampoline. Or if you like threads, you could do a new thread, for instance. So it's, concurrency made easy. Welcome to the real world. Now we get, things get real. We are going to create a real app, and we are going to use retro lambda because we are stuck and we are not using Kotlin already. So we like the arrow, and we are using retro lambda. We are using Butterknife because, as you know, that the only person that can do an Android app without a library by Jake Wharton is Chuck Norris, and I'm no Chuck Norris. We are using Lombok because I'm too old for getter and setters. Really, let's use annotations. Retrofit because we want to deal with a REST API, and it's the only proper way to do it in 2015. And I need to load image from the internet, so I'm using a universal image loader. You could use Picasso, Fresco, or everything. But I like this one because it's easy to use and it works. This is the app. Basically, I'm fetching the most popular users on Stack Overflow, and I'm providing a list, a picture, name, city code, reputation, and city, and forecast from 2 endpoints. We are creating a Stack Exchange API manager and Open Weather Map Service API manager. This is retrofit. How many of you use retrofit? Come on, guys. OK, perfect. So you know these things. I'm not using the 2.0 because it's not stable-ish. I'm using JSON schema to Pojo because I'm too old to make manually the Java Pojo objects. Come on, we are lazy. We are mapping the interfaces to the API, and we are creating a manager to keep stuff at a bit in order. And we are providing a get most popular user SO users as a manager methods. We are not getting the perfect match from the API because we are getting this user response, and from the user response we are mapping and extracting the users list. So we have a stream and we manipulate it to create the stream we need. We need a list of users, and we apply a map. We do the job on IO scheduler because it's a network call. We get the result on the main thread because we are pushing the list to a list view. From an Android side, easy stuff, adapter, recycle view, the manager, please use Dagger. How many of you use Dagger? Dependency injection. Oh, come on. Actually, yeah, nice. We have this refresh list function that basically started the refresh progress bar, subscribe, get the most popular Stack Overflow users, and when the users come in, we stop the progress bar and we refresh the adapter. When something goes wrong, we print log error message and we stop the progress bar. We have the first half of the app. How many lines of code is that? Come on. And we're going further. We are fetching the city name. We are creating a new API manager for open weather. So we are using at the same time 2 APIs. For every element in the list, we are retrieving the weather. We are filtering out the results that are wrong. So we can filter for null, for an invalid weather response. And when we have the city, we have the URL, and we can use another function, it's load bitmap, to reactively, asynchronously fetch the icon and inject it in the sequence, and return it on the main thread. So when the icon comes in, we can set the image bitmap, or we can print an error. And we have everything reactive. With how many lines of code? Guys, it's a mindset switch. You have to think that you are not in charge of the data. You are enjoying, you are subscribing politely to a sequence and that you can manipulate to create the sequence you want. It's like a river. They flow. You can filter a river, you can transform a river, you can combine 2 rivers in one, and it will still flow. At the end, it will be the river you want it to be. So, be water. And last thing, this is my contacts. These are my contacts. I'm using another method, combine latest, that it's like the zip, but it combines the last emitted item if one of the 2 observable emits it. So I'm emitting just my username, and I'm emitting 2 strings in the second observable, and I'm combining them. At the end, I will have 2 strings. And that's it. Thank you.